Hey everybody, today we'll do another video, and today I am going to use this software. It's called OneNote, which a lot of people use it, but I never use it for this purpose. Okay, so basically what we're doing is we're doing what is called root mean square, right? All right. So now what we're doing in this is basically we're calculating the average AC voltage average, right? So that's what we're doing, right? Now, to do this, we will have to do some, of course, I will just, delete that just to have the introduction of what we're doing. So basically, voltage is given as B of T of some, sinusoidal function, right? So sine of pi, right? Well, this is the thing, right? So we can say that we multiply in that pi some times some omega value, right? We call it, for the meantime, we can call it n, right? And n pi, right? We can actually take the average of that, which is called also, it's going to be divided by n, right? Okay, so now if you think about it, right? So basically n, right? And then we will take the value and then we square it, right? That is called square it, and then take the square of the square. Okay, so add the average, right? So okay, so we add the squares, right? Then after we add the squares, right? Because we take an average of each one of them, and then we will square, right? And we will square those values, and then we will take the square root of the squares average. That make any sense, right? Now, okay, so let's do a little chart over here so we can have a better understanding of what is going on here, right? So what I will do here is I will make a chart that is going to be probably going to be bigger than this. Yeah, but yeah, it's going to be bigger. I will just keep going. I will keep adding rows and columns, right? So first we'll have a time, right? Then we will have what is called value, right? So value a square, value square, actually, right? So keep it. I'm still learning how to use this software, so bear with me. So let's say, for example, that we have time, and then we have we have voltage, and then we have square, right? So we square the voltage, right? We square the voltage. Or you can say, yeah. I'm trying not to take too much room here because B squared, right? Now we square the voltage. Okay, so now we will take the average of the voltage squares, right? And then after we square that voltage, right? So now, let's say for example here, so let me just start with sine of, let's say for example, let's say for example 1 times pi, right? You take that sine, make it choose the calculator is in radians, right? But remember, we taken the average of that. So let's say that we picked n equal to 10 values, right? To make it easy. 10, right? Now we take the pi. So we take sine of, so pi is being divided by 10. But remember, pi is going to increase. Pi is going to increase because we've taken that v of t is equal to sine of n times pi over n, right? So I wanted to make it sure that we understand what is going on here, right? So, you know, that's the whole purpose of this. So not too much about, you know, but I am going to write a little MATLAB program real quick. So, okay. So basically, so b of t is equal to sine of sine of n pi over n, right? That's what we're doing, right? So now, in this case, we have when I do that, it's going to be pi. It's going to be pi over 10, right? And that value is actually 0.309. And you can add more digits if you want to be more accurate about it. I'm not gonna, you know, do it right now. So you take 1, right? Pi, right? At time t over 10, right? And then you're evaluating at that the voltage value for that. The voltage value, and you gotta bear with me because like I say, it's the first time I'm using this app. So the voltage value here is, I don't know if it let me move. Nope, it doesn't let me move it. Okay, never mind. So the voltage value is 0.309. And like I told you, this is going to be kind of crazy because like I said, I am still learning how to use this, and it's not easy. It's not easy software. Okay. So let's do this again. Okay. So let's put these values. Okay, first on here. So the second is sine of 2 pi over 10 equal to point something, right? It's going to be equal to point something, obviously. Now let's do this. So let's do sine of 2 pi over 10, and it's equal to 0.587. It's going to be equal to 0.587. Then I do the next value, and I gotta make sure that this 10 look like a 0. So then that's better. So sine of 3 pi over 10 is going to be equal to 3 pi over 10 is equal to 0.809, and then sine of 4 pi over 10 sine of 4 pi over 10 so sine of 4 pi over 10 is equal to 0.95 0.951, and sine of 5 pi over 10, and that is going to be equal to, which is, it's basically a half pi, right? So technically, normally that is 1. So that is equal to 1, and then sine of 6 pi over 10 is going to be equal to what? It's going to be equal to sine of 6 pi over 10. That is equal to 0.9510 again. So basically, it seems like it's kind of oscillating, isn't it? As you can see it. So, okay, so technically it's 9, so it's 951. Then we do sine of 7 pi over 10, and I'm sorry because this pi look like a weird, but look like a lambda, but it's not lambda. Okay, so let me just do this again. So, right, so 7 pi over 10, and that is going to be equal to sine of 7 pi over 10, that is 0.809 again, and then we do sine of 8 pi over 10, sine of 8 pi over 10, right? Sine of 8 pi over 10, that's going to be equal to 0.587 again, so it's 0.587, and then of course it's going to be equal to so 9 let's do this real quick. So 9 pi over 10. So 9 pi over 10, right? So that is going to be equal to back to the other side of that graph, right? So basically we're oscillating. That's what we're doing here. And that makes sense because that's what electricity does. So 9 pi over 10, and that is equal to 0.309 back again. And the last one we do sine of 10 pi over 10, and you know that this cancels out and this should give you a 0, right? Because we go back to, we start off, right? We're back to 0, we're back to 80 degrees. So pi of sine of 80 degrees is basically half a circle, so we end up at 0 right now. Now let's put this in the table, right? So let's put this in the table, right? So now let's do this. So now let me do a table right here. So let me make it kind of good space, so I don't have to deal with that tiny little space, because I think this software is giving some hard time. So we have a time, and we have what? We have voltage, right? And then we have what? We have V square. Right. So right here at this moment we say that was pi, 1 times pi over 10, and that for that value was 0.309, and then it's going to be crazy with this software, right? So now we square that value, right? So we take the square of that, and unfortunately this doesn't look like a 0. Okay, so let me just redo that. And again, I apologize for this, but again, you know, it's nothing I can do about it. I don't use this in my job, so I am not really practical on this type of software like this. Okay, so now so that I guess it looked like a 10, right? So now we squared that. We square point 0.309, square that, and it's going to be equal to 0.954, right? Now we make it separate the values, right? Now we do the next. So then we do 2 pi over 10 here, and then we do the next, right? So next is what? So it's going to be, technically it's going to be pi over 5. You know, you cancel those, it's still going to be the same. So pi, so right, 10, and that is, and then we square that, right? So we square the number, and then of course we get, so we take the value and we say that it was 0.5587, and then we square that and we get 0.34545, right? I'm not gonna just, you know, I am just approximating this. I'm not gonna, write too many digits. I don't have enough room for this, and I just, don't feel like it. Okay. Next, we do 3 pi over 10, right? So 3 pi over 10. And in this case, at 3 pi over 10, we get 3 pi over 10, we get 0.8, 0.8. So we do 0.809, right? Take 0.809 and square it. 0.809 and square that in, and we get what? We get what? We get 0.65. 0.6. We get 0.6. Oops. Okay, so it's going to be 0.6654. Right, so now we do the next, right? We do the next. And the problem with this is, this is not really hard. It's just a process with the software. Okay, so now, this doesn't really look like a 0. Okay, never mind. I'm sorry. Okay. All right. So now we do the next one. Of course, right? Is we're going back to, if you cancel that by 2, it's basically saying the same thing as, right? So sine of 4 pi, which is already there, right? So pi divided by 10 is basically the same thing as the previous value, which is, so it's right here. So 0.951, and then nope. Control C, Control V, there you go. Okay. All right, now let's do this. All right, so now this right here is going to be pi. So it's 4 pi over 10. Next, we square that. And we get 0.904, right? So now we do next. We do what? We do 5 pi over 10, right? And 5 pi over 10, we know that is equal to 1, right? Because it's 1/2, right? And then we square that, which is 1, right? Now, oops, this is ridiculous. There you go. Okay, this is all right. So now we see. I am trying to use this and I tried to draw it straight, but it just keep going weird. That's odd. Okay, anyway. Okay, so next we do what? We do 6 pi over 10, and then we do, and the value for 6 pi over 10 is 0.591 again, right? Okay, so then 6 pi over 10, and that is equal, and then that is square, we square the value, and it's again, it's the same value oscillating, like I said. So technically right here, we just do this. Oh man, let's see, okay. All right, so now we do 0.904. Right now, if you think about it, we're oscillating, right? So yeah, so that's the whole purpose of this is 91. Nope. 9510. 951. Now we do 7 pi, right? Which is 7 pi, the value is at 0.809 again, 0.809. We square that value. So right here is 0.809. And we square the value, and then back again we go up to 0.654, right? So now we, right, and then it's pi over 10. All right, now next we do 8 pi over 10, which if you know, it's going to be like 4 pi over 10 again. I mean, it's just basically, you know, the same ratio actually. So at 8 pi over 10, we get the same thing as back here as this one. See, it's just a ratio, right? So now, so we go back again, and we do pi, and then the value of this is 8. Oops, it's going to be 587, and just keep going, right? So now in this case, square that 0.87, 0.587, and then we square that, and we get 0.34 again. We get 0.344 again. All right, so now that's start. Okay. Right. So. Right. So. All right. So now we do next. Okay, so it's getting close, right? So you have a feeling that what is going to happen here is that we going in the other side of the graph. So now, yeah, so now we do what we do. We do 9 pi over 10, which is that value right there that we got, which is what? Which is 0.349. No. Nope. This is 0.309, right? 0.309. Then we square that 0.309, and then we square that, and we get again back to 0.09, and then actually it's a 0. I don't know if I put a 0 up there, but whatever. I will check it out. So it's point. So right here is point 0.095, right? And then of course when at 10 pi, this is 10 pi over 10 pi, and that value is 0, right? So oops, right here, let's see. Okay, so we know that at that point, this one right here, I need to do this. I need to make it, right? And then this one, all right. And I'm sorry, guys, about this chart, but it is what it is. I am getting used to this software. So basically, the whole purpose of this is to analyze this. And we know that when this cancels out, that's going to be 0. Those 10 cancel out, is going to be 0. And then the value of that square is 0, right? So basically, we back, right? So now, right here, let's see. 9 pi over. Yeah. Okay. So let's now that we have this, that doesn't look like like a good chart, but it's okay. I mean, it is what it is. I'm not gonna try to fix this because I am just trying to show how we get the numbers right. So now that we have this little chart, all right? So now that we have this little chart, which looked like weird, like it looked like a road to me, but it is what it is. So okay, now this is what we got, right? So now we need to do the following. So we need to take an average of that. So what we do is the following. So we do the following. So in the case of this, so if we add all these values, okay, so let's add this one. So okay, so okay, 3, come on, let's see. Okay, so now I got a 0.309, and then square that to make it sure that now this number is wrong. Actually, I noticed that is wrong, but we will have to see what is going on here. So let's see. So pi over 10, right? So yeah, so basically this right here is and this thing doesn't allow you to, okay, so this is 0, that has a point in there, okay, so then it's 9.5. That's what it is. Right, now you're adding all those numbers. So add that, right? So plus 0.345 plus 0.654 plus. So technically what we're doing is adding all the squares, right? To make it sure that you understand, I am adding all the squares. And then plus 0.904 plus plus 0.904 again, plus, and you can see that 0.904 is just beside the 1. So you can actually see where that is making the maximum, and then, yeah. So I think you guys can see that. Okay, so now plus, back again, 0.654 again, right? Plus 0.344 again, plus 0.095, right? And then plus 0, you don't have to do that. But, you know, because we need to count that, so for the average purposes. So let me just verify that I have all the numbers. Let's see. So we have 0.9, 0.00, okay, 95, 0.095 plus 0.344 plus 0.654 plus plus 1, right? So yeah, so after I got all that, it's basically I am getting, if I am, you know, doing this right, which it looked like I just want to verify. So 904 plus 1 plus 0.9 plus 904 again plus. So you can actually see that plus 0.654 plus 0.344 plus 0.95, right? Basically, I am getting a number very close to 5. I just want to verify that, right? So I am okay. So what I will do, I just make this that the total of this, so it's going to be equal to 5, right? Now what we do right here is we divide it by n value, and what is the n value, right? So this is going to be the numbers of, right? So we have 1. So we have a 10, right? So we have a 10, right? So we have 10 values. But how do we do the root mean square? Root mean square, right? Root RMS is equal to the sum of n, right? The sum of n squares, right? Of n squared, right? Over the n value, right? Over the n value, right? But then what happened? You take the square root of that, right? So you take, and this for some reason it doesn't. Okay, so this will be the average now, right? So will be 1/2. In this case, will be 1/2 because n is equal to 10. But we squaring it, right? And then we taking the square root of that, which mean that we doing what is called okay. So in other words, we doing this. All right. So we doing n squared over n, right? So in this case, if we do that, it's going to be what? It's going to be equal to 5 over 10, right? So take the square root of the whole thing, and remember that this let me just do this again because I don't want to confuse anybody. This right here, this right here is 5 over 10, right? When you take the square root of that, it's basically you taking the square root of both, right? So technically, so you're taking the square root of 1/2 because you need to divide that by 1/2. So basically, you're saying that RMS equal to the square root of 1/2 in this case, right? You're taking the square root of 1, it's actually 1, right? But if you take the square root of 2, right? That is actually 1.41, and then you take 1 divided 1.41, 1.41, and then when you do that, right, take the square root of that, take the square root of the top one first, and then the bottom, right, and then you divide the square root of the top by the square root of the bottom, and you get that it is 0.0707 approximately, right? So that is the RMS value. Okay, so now let's put this stuff in MATLAB. I'm sorry guys, that's going to get probably a little long this video because I am learning how to use the software, but anyway, I think you understand what is going on here. In this case, it's going to be, so you divide them by, so 5 over 10, right? And it's 10, right, in this case. And then we took 5 over 10, right? And took the square root of that, right? And then we found that it's 0.707. And interestingly enough, when you have a pure sinusoidal waveform, that is actually the root mean square, right? And then interestingly enough, when you do that, let's say for example, you take $120 and divided by 7.07, right? So basically, what would be the peak value of the average voltage, right, of 120? When you do that, right, you're taking 120 volt. That is one example. So peak value, peak value of the voltage, peak, right? So peak is equal to RMS voltage, RMS voltage divided by, right? So what is the RMS voltage given? Was divided by the root mean square. So what happened here is the following: if you take peak voltage, right, 120, right, 120 volt over 0.707, and it's going to be equal to approximately 170 volt. When you have now any power source, right, that is coming 120 volt. In this case, right, so the peak value of that is actually 100, very close to 170 volt. Right, so now, okay, so now let me just erase this because I am just giving an example of that. Okay, so now let's jump to MATLAB a little quick because this is getting too long, right? So let me reduce that. Go to MATLAB. Go to MATLAB and let me just erase this because, right? So let's do this real quick. So for example, so let's see, for example, real quick here. So, and what I will do is the following. So I will probably not explain about too much about what this MATLAB will be doing, but I will just declare a value of a num value, and I will make that equal to 10, just to make it simple, right? So to make this simple, equal to 10. Now I will do n value, which is also equal to 10, right? We make it sure that that will be the multiplier. The num is going to be the pi multiplier, right? And the bottom is going to be the n value that we actually, the n value is going to be the one that we will, yeah. So I will explain it. I will take the pi multiplied by num, and then I will take that num and then divide it by n, right? So now I will do x, right? And I will do x, and I will create what is called a line space to line the vectors evenly, right? So linear, it's called linear space vectors, right? Linear space, right? Now here we will create what is called, we're starting from where the sine function is starting from 0, right? If we start on 1, it's going to create a shift and it's going to drop it when we want to start at 0. So we go from 0 to num, right? To the value of what we select, right? Now, and then we put a semicolon to hold the value, because otherwise it will be displaying this stuff on the screen, which we just want the plot. We don't want a number. That MATLAB, usually you need to put that stuff in order, right? Now we will say that y, right? Y equal to something, right? So sine of, right? Sine of what? Sine of what? Sine is going to be of the, we need to plot this, so we need to even the vectors, right? So what we need to create is, we need to create a line space in between that evenly distribute that, right? The linear space vectors, right? So we need to do pi, which whatever, n, I'm sorry, x, the linear space times pi, right? Times pi. And one thing about beautiful MATLAB, that the functionality, is that it will calculate that as actually 3.14, which is pretty cool, I think. Now, what do? We take that, right, and then we calculate the mean, right? A square, right? So what we do that? So we take the mean square of the y value, right? So we said mean. We said mean. I mean, you can do whatever you want in this, and then you can say SQRT for a square equal to mean square, right? Just this is a mean square. This is not yet the RMS value, right? So we just add in the squares, right? We taking the y, we squaring it. Okay, so how we do that? For this one, what we do is the following. So what we do is y, we put y, right? So we put y, and then we put a dot, right? And then we put a square, 2 like that, right? With a little caret. That is saying that I'm taking this vector of y and I'm squaring each vector of y. That's MATLAB doing. MATLAB is a little different because MATLAB it work with matrices, right? Now we're doing the RMS. So now we're doing this. This is a mean, right? Now we're taking the mean. Now we will take the square. RMS, right? Root mean square is going to be equal to SQRT. Now notice that I am doing SQRT, right? So actually sqrt, just like that. Right now, notice that it's telling me, MATLAB is saying, okay, I recognize the function that you enter is a square root. It's the square root of something, right? So now what I will do, and I said, okay, I wanted the square root of this, right? So I want the square root of that, right? So I want the square root of that, and I will paste it over there, right? Now what are we doing here? What we're doing is taking that, right? And then we will divide that by what? By n. By n. Right? What is the n value? N value was 10. Now, put a semicolon in there and let's keep going. Now, next we will plot the root mean square. Plot. It's another plot function that exists in MATLAB that allow you to plot things, right? Now, plot RMS. Plot RMS, right? And then we put a comma to separate that, right? Now what we'll do is, in here we'll put a little symbol like that, and we put lines. 2 lines like that to create a line in that specific, and we call that blue. Okay, so I will create a dotted line blue, right? Now I close the parenthesis and put a semicolon. Now I say plot, right? But then I have to say hold on, right? I want to hold on that plot until I say, okay, now plot everything in the bottom. Hold on, right? Plot it, but hold it, right? Now, next, we do a for loop. I said for, right? In MATLAB, it's like I said, it's a little different for num, which is the value that we declare on top, num equaled, okay, num, okay, the for loop is written like this, for num equal to, we start from 1, right? Why? Because that is, if we did do 0, then not going to calculate anything. Pi is going to be multiplied by starting from 1 times pi, which is pi, right? And so forth, divided by 10, isn't it? Okay, now, so we go from 1 to 10, right? Now, in this case, for a for loop, we put n, right? And that will end that. But right here in between, I will say plot now. Well, I'll just say plot. I'm not say plot now, right? In MATLAB, I just want to make sure that I don't confuse anybody. So, okay, so now I will say y, which is the sign, right? And then what we'll do is the following. So I will put a comma in there, and then I will make little squares to identify where the changes in voltage are. Okay, so, and it's called KS, right? Now, and then put a little thing like this and put a comma on it. All right, put a comma. For some reason. Okay. Put a comma on it. Then I go next, right? So then I put what? I put the following. I will change that to a marker face color, right? And I will say marker face color, right? And then I will say marker face color, and of course I need another little thing right here because That way MATLAB is not saying that I am just trying to create something that he's not understanding. Okay. So, and then right here I said KS. So KS. Okay, so now I say KS and then put a semicolon like this, and then we put something like that, right? Now what we do here is the following. So actually no, nope. Okay, so now what we do is that I don't know why this is keep doing some weird stuff for me in this case. Okay, so okay, so now okay, remember MATLAB is something that you need to separate it by, you know, need to separate it by commas and making sure that you have the proper everything. Like, okay, so now we get a little code right here, right? So now let's try to see if we have any errors. Okay, so now you can see. Okay, so now we have two plots, right? So we have one plot that is representing the sine wave in the little, you know, dotted line, right? That's the sine wave. And as you know, it's periodic, starting from here. And of course, you know, this is 0, right? And then it's a little, you know, it's not going to be exact, right? Now, right here, I am saying that, okay, so this is the periodic function. And you can see the sinusoidal wave. This is the root mean square. You can see at this point, see, you got some numbers in there. See, remember what 0.32 was one of them. So at that moment is 0, and then it goes like this and got the maximum, right? And then you go back, and technically this is the root mean square, as you can see it. So root mean square is taking the average of these two values, negative and positive, and plotting it, right? So okay, so let's do this again. Okay, all right, so you can see that like this, what is the value for this, right? We said that was about 0.3 something, right? And this, right? See, very close to the value that we got. See that? And of course that's going to be, it's going to be 1. Maximum is going to be 1, right? So we go back to the one note. The first number we had was 0.30, right? Was with the first number. The second number is 0.58. And over here, when we go to the MATLAB, we go, see, 0.312. And then we get next 0.59. We got a 0.58, right? This 0.59. So it's very close. We 0.8, 0.8146. We got 0.80. See, 0.81. It's very close. So I mean, I didn't round the whole thing up, but yeah. So basically, what I'm trying to say is that this works. This calculation, you've proven that it works in the MATLAB code, and that's how we analyze AC electrical systems, when you have to use, like, maybe some type of analytical software, like, you put a system and monitor a certain voltage. If the voltage is having like some issues, and the voltage, the equipment you got to plug in has a software on it, and it will display graph like this. It will display whatever was a normal sinusoidal wave, and in the middle will will say this is the root mean square voltage, and then so that's how we do it. The voltage, and that's how we do root mean square using the AC voltage, right? So thank you for watching, and I see you in the next video.